Hello, my name is Yunus El Morabet. Today I will be presenting my research on how an adaptive AI coach can support cybersecurity decision-making during direct attacks on AI systems. AI systems are becoming central in healthcare, finance, and cybersecurity, but because they learn from data, they are vulnerable to attacks like data poisoning, manipulation, and phishing. These attacks can create unpredictable or harmful outcomes. In this project, I look at whether an adaptive AI coach can support human workers in real time, especially when stress and urgency rise. The goal is to see if the coach can reduce human error and overall risk during cyber attacks on AI platforms. We simulate a realistic cybersecurity environment where an employee monitors threats like phishing emails, unusual logins, and system slowdown. The AI coach observes the same events but also tracks human states such as stress and urgency. When stress becomes high or the employee hesitates, the AI coach can step in, for example by suggesting the report earlier or by helping the employee focus on the most important threat. Over time, the coach adapts to how the employee behaves, offering more personalized support during future incidents. To understand how our model works, we use adaptive network modeling. Each part of the system is a state, like stress, urgency, or the decision to notify security. These states influence each other through connection weights that change with experience. That's how the model learns. We use two key functions. The first, allogistics. This one checks how close the input is to a threshold. It lets us model smooth or sudden changes in behavior. The second, step mod, adds timing. It activates the states only when certain time conditions are met. Each state also has its own speed. If stress builds up fast, but writing a report takes longer. So stress builds up fast and writing a report takes longer. All of this combined allows the model to simulate realistic evolving behavior on the cyber threats. And that's what you can see also here in the PowerPoint. The function of the allogistic and the one of step mod. The employee model contains the employee model contains 45 states. When a phishing, if you can see here, when a phishing email is detected, threat urgency and emotional stress rise. These will affect the decision stage, such as investigate further or notify the team. Learning happens through the W states. These strengthen connection based on past mistakes. There are also HW states that detect when learning is too slow and signal the system to adjust. This models how an employee learns under pressure, including moments where stress slows down correct decisions. The combined model has 60. The designed adaptive network model of the AI coach has 76 states. The AI coach detects the same threat signals but also evaluates the situation more systematically. For example, urgency influences the notify security team through a W state that adapts over time. In the second order states adjust the learning speed if the system notifies repeated failure. Monitor states checks and the monitor states checks whether the employee's action match with the AI expects and only activate when behavior deviates. This allows the AI coach to stay stable under stress, learns continuously, and intervene only when necessary. This is a simulation of the result of the employee. In the employee simulation, early threat signals activate quickly. between T is 2000 and 4000, we see rising stress and urgency, which could really push the employee toward action. Eventually, the employee decides to notify the security team, but only after stress builds up. The passive responses like doing nothing stay low. The key point of this, after all, is that stress slows down the action and learning is weaker under the pressure. The employee acts, but not consistently or quick enough. For the AI coach, the W states connecting urgency to the notify action rises quickly and stabilizes near full activation. So you can see there's a small dip during high stress, but the AI coach recovers fast, showing a robust learning even in difficult conditions. Monitor states only activate when needed, meaning the AI coach gives selective, not constant feedback. This makes it supportive rather than intrusive. Overall, the AI coach learns faster, stays stable, and guides decision more reliable. And you can see also here the dip after these 2000, and then it recovers. What if analysis? So we tested how learning changes under different pressures, adjusting both urgency levels and the difficulty of taking action. Our key findings were that when reporting is easy, learning is strong, around 0.75. When reporting becomes difficult, so high threshold, learning drops down to about 0.5. The worst case is when there's high urgency and high threshold, learning becomes weak and unstable. This shows us that stress combined with difficult decision conditions strongly reduces learning and responsiveness. The AI coach, however, maintained an average learning value of 0.9, far greater than the one of the human model. So now we are at the risk assessment results. Here we compare the risk of failure for the employee and the one of the AI coach. If we look at the one of the employee, we see that there is a probability of low activation of 60% and an impact value of 8. So there's a total risk of 4.8. On the other hand, if we look at the AI coach, we see the probability of low activation is 30%. The impact stays at 8, but the total risk drops to 2.4. This means that the AI coach cuts the risk almost in half. Additionally, its what if learning average 0.9 is much higher than the employees. The conclusion is then that the AI coach is more reliable and less risky than the human operating alone. Discussion and conclusion. This study shows that an adaptive AI coach can support cybersecurity teams during AI attacks. Employees under pressure show slower learning, delayed action, and inconsistent decision-making, especially with high threshold and high urgency. The AI coach, however, learns faster, stays stable under stress, intervenes only when the behavior deviates, and reduces overall risk significantly. These results are based on simulation, so future research should test this with real-world security teams and explore human factors like trust or fatigue. If validated, adaptive AI coaches could become an important part of defending defending AI systems against modern cyber attacks. Thank you for listening.